Hello everyone, I am Rakibul Hassan Khan, Assistant Professor of Assam Downtown University. Today I am going to discuss about movements of lens. So, movements of lens means the power of an unknown lens can be determined by neutralizing it with another lens of known power. Neutralization is based on the fact that if you look at an object through a convex or concave lens and move the lens from side to side, that is right and left or up and down, the image that you see through the lens will also move. If the lens has no power or has been neutralized by placing a lens of equal power but opposite sign against the unknown lens, then there is no image movement. Here, movement of lens helps to find out the power, whether patient is having plus power or minus power, and we will determine the unknown lens power by a known lens power. We will move the lens up and down side and right to left side. Here, if we neutralize -1 diopter spherical power by +1 diopter spherical, then the spectacle power is -1 diopter. It means -1 diopter spherical power we will neutralize by a opposite sign, that is +1 diopter spherical, but the spectacle power is -1 diopter. Next, movements of lens. Number 1, a plus lens moves the image in the opposite direction to the lens. Here, if we move the lens to the right side, then the image will move to the left side. If we move the lens upside, then the image will move downside and vice versa. It means, see the diagram, if we will move the lens this side, then object will move opposite direction. This is opposite movement, against movement. If we will move the lens upside, then the object will move downside. Next, number 2, a minus lens moves the lens in the same direction to the lens, that is with the movement. Here, if you move the lens to the right side, then the image moves right side. See the diagram, if we will move the lens upside, then object will also move upside. If we will move the lens right side, this side, then object also move right side. Next, number 3, a spherocylindrical lens causes scissoring movements on rotation. Here, if you rotate the lens about its optical center, the image of a cross will appear to scissor. The principal meridian are determined by marking the orientation at which the cross lines are perpendicular. See the diagram, we know we have two meridian in a lens. This is one meridian at 90 degrees, another meridian at 180 degrees. Here we can see the scissor movements in those patients who are having cylinder power, that is astigmatism, because in this lens both meridian having different power, these two meridian having different power. We will use cylinder lens to focus any object, and if we will rotate the lens, then the object shape will be changed or spoiled, and we will see these types of movement, that is scissor movement. Next, number 4, a lens with no power causes no movement. Regardless of lens movement, the image remains stationary. Here, after moving the lens right side, left side, up and down side, if the object's movement is absent, then there is no power. Hope you all have understood the movements of lens. Thank you.